Saudia, and this is my co-host, Ali.
Today we'll be presenting naming ionic and covalent compounds, or dummies.
First, we must ask ourselves, what are ionic compounds? They are a group of two or more elements or polyatomic ions. One atom or polyatomic ion loses one or more electron, and its partner gains the ones it loses.
Since positives and negatives attract, these ions are now attracted to each other and form an ionic compound. But do any of you know how to name them?
Me no.
Well, before you name them, you have to consider the rules for naming them. The first rule is that the first element's name does not change.
Any polyatomic ion's names also do not change. Otherwise, the end of the second element's name changes to IgE.
The third rule is that the positive ion goes first and the negative ion goes second. In simpler terms, this means that the element furthest left on the periodic table goes on the left, and goes on the left of the name, and the furthest one to the right goes on the right. Simple as that.
Interesting.
So, if you put scandium and bromine together, you will get scandium bromide. And the name of nitrate and calcium put together would be calcium nitrate.
But if the periodic table indicates that there is more than one possible ionic charge for an atom, you can take the charge you are using and put it in Roman numerals after the element's name. For example, rhenium-4 dioxide.
Now that you've learned how to name them, let's walk you through making their formulas.
We'll take scandium bromide for example. Scandium's ionic charge is 3 positive, and bromine is 1 negative. You simply switch the charges but don't indicate whether it was positive or negative. Since bromine's was 1, you do not have to write it in the equation. The scandium bromide equation is ScBr3.
But if your charges were something like 2 and 4, you have to simplify them to lowest terms.
There are instances when you have to put the polyatomic ion symbol, such as when dealing with something like cobalt-3 nitrate. The chemical formula is CO bracket open NO3 bracket close 3, because the 3 is outside the bracket to apply, and it applies to the whole nitrate.
We're going to the most exciting part, the special cases of polyatomic ions.
Sometimes the number of oxygen atoms in a polyatomic ion changes. When there is one more than usual, the prefix per is PER is added to the beginning of its name, and the suffix ATE to the ending. For example, PO5 to the charge of -3 is perphosphate.
If there is the usual amount of oxygen atoms present, then the polyatomic ion's name ends in ATE. For example, CrO 4 to the power of 2 minus is chromate.
If there is one less oxygen atom than normal, the name ends in ITE. So, SO3 to the charge of -2 is sulfite.
Lastly, if there are 2 less oxygen atoms than normal, the prefix hypo is added as well as the suffix ITE. Therefore, NO 1 minus would be hyponitrite.
Now, let's talk about the covalent compounds. There are compounds whose elements share electrons. In a covalent bond, atoms share electrons so that each has a complete valence shell.
Covalent bonds usually occur between a metal and a nonmetal. Let's make a covalent bond between phosphorus and chlorine.
Phosphorus has 5 valence electrons, less than chlorine, which has 7. So we put it in the middle.
When the sharing of electrons is over, we must have 3 chlorine atoms to make 1 phosphorus atom complete.
All the previous rules for naming ionic compounds apply, but there are now more. Because there is 1 phosphorus atom, nothing is added to the beginning, but there are 3 chlorine atoms, so tri becomes chloride's prefix.
So when phosphorus and chlorine bond, the name of the covalent compound form is phosphorus trichloride.
Phosphorus and chlorine are bonding.
Now, we will look at how to make the formula for phosphorus trichloride. The symbol for phosphorus is P, and there is 1 of those. And the symbol for chlorine is Cl, and there are 3 of those.
So phosphorus trichloride's formula is PCl3. We will now educate you on the different types of covalent bonds.
It's simple. If an element shares one of its electrons, it is a single bond. If it shares two, it is a double bond. And if it shares three, it is a triple bond.
This has been naming ionic compounds and covalent compounds for dummies.
Yay,
Yay, it's over!